me turn off my lights. Moment of truth. 3, 2, 1. Just kidding. How's it going, guys? Dylan's Outdoor Garage. Welcome back to Dylan's Outdoor Garage Home Edition, episode 2.5. If you were wondering why it's 2.5 and not part 3, well, at the end of part 2, links to that video will be down in the description down below and up in the info card, where we replaced the bulbs successfully and then went to go come back after an hour or so to do the outro and turn the lights on. One of the light fixtures stopped working altogether. Yeah. Now I don't have any lights at all. And I was thinking maybe it was just maybe the bulbs maybe weren't set properly, and finding out that there's no power going out at all. So my thinking is that the ballast in there was already failing before I replaced the bulbs, and then when I put the new bulbs in there, it finally just went kaput. So in today's episode, I'm going to show you how to do a direct wire replacement by taking out the old ballasts in these fixtures. If you're wondering what the ballast, so inside of here is a magnetic ballast, which basically helps ignite and turn on the old fluorescent tube bulbs. With the LEDs, you don't need to have that ballast in there because there is no mercury or fluorescent filaments inside of these new LED tubes. These are just LED strands, and they just need the 120 power. So with these ones, you have to do a conversion by taking out the old ballast fixtures and to make it a line voltage by taking that out and then splicing the wires together to make this a constant 120 power circuit with no ballasts involved. Without the ballasts being installed, then that gives you a guarantee that you're not going to have to worry about down the road replacing or taking out that ballast in your fixtures when the ballasts do eventually go out, because they do still ignite even though you have the LED bulbs in there, that you've got the replacements that you just pop the old ones out, put the new ones in. If it was my recommendation, I would just go the extra step and also do a little bit more extra, spend the extra money to do a direct wire. With that, you don't have to worry about the ballast going out, and then you have to go up on the ladder, take all of them out, take the ballasts out, and and convert it down the road again, and then not having to spend extra money to get the correct bulbs when you can just do it the first time. So let's take a look at the things that we're going to need to do this safely, and so that you can do it yourself. I do want to give you a caution. If you are not 100% confident that you can work on any electrical wirings or exposing any high voltage components, then stop. Do not attempt to do this repair unless you are 100% confident that you can do this without causing harm to yourself or damaging any components. If you are not confident that you can do this yourself, then please don't hesitate to contact a licensed electrician or a handyman who is more than willing and is capable of doing the job for you. I am not a licensed electrician or a contractor. I have worked with high voltage and have worked with electrical wirings in the past, and so I know how to safely work around the wires and how to do proper lockout tagouts and how to properly work on the system without causing harm to myself, others around me, and or the components that I'm working on. So I'll show you how you can do that safely to protect yourself and the components. And let's jump right into it and look at the things that we need to get this job done. First thing that you're going to need is that you need the new LED bulbs. I picked these up at Lowe's. It's by General Electric, and you got to make sure, if you watch part 2, that you want to make sure you get the correct bulbs for your application. Just to do a little review on all of these bulbs, on the old ones, they have, if the letters are not rubbed off, there's letters of F32T8, basically saying it's a 32 watt T8 bulb. The T8 stands for the diameter of the tube. T8s are 1 inch, and then you have ones that are 5/8, 1.5 inch. They also have different lengths. These ones are 48 inches long. You want to make sure that you get the proper ones to work on. So with these ones, it is a 32 watt T8 replacement, type B. Type B means that there's prongs on both ends. Some of them have only a single prong. Some of them only have a prong on one side and not the other. You want to make sure you get the correct ones. This one is for direct wire. It converts T8 fixtures to line voltage. The ones I showed in part 2 were replacements, basically allowing you to leave the existing ballasts and put in just the bulbs without having to do any retrofitting or conversions. The next things that we're going to need to do it is some tools. You're going to need either a drill if you have some screws that are holding in the cover, drill bits, flathead screwdriver. If in my case I have minor pull tabs that are pinched in to hold in that center panel. Since we're going to be converting this to a direct wire, per the directions from this installation, it recommends installing a 1 amp fuse on the hot side. So that way that it can protect itself from any surging power voltage, and that it will burn the fuse first instead of damaging the LED bulbs and causing those to get short out. You're going to need wire twists. I have a couple different sizes depending on this diameter of the gauge of wire, and I also have my little tray of ones that I've bigger of. Zip ties for wire management. And then you have your fuse holders. I picked these up at my local auto parts store because Lowe's and Home Depot didn't have any glass fuse holders in stock. And then you also need your 1 amp fuse to go inside of here. And then you're gonna need your wire crimpers, wire strips, and then also wire snips to be able to cut the wires and also to cut the zip ties if you're doing some wire management. A couple safety tools that I highly recommend that you get. You can either, once you turn the power off, you want to make sure that there's no power coming from those ballasts. And while you're snipping the wires, you don't want to cause a spark or an arc while you're cutting wires. So you can do 1 or 2 things to test if there's power going to those ballasts. You can use the traditional voltmeter by testing to see if you have any power going to it, or you can use this pretty cool tool that you put up to the wires, and it will test electrical voltage current through the wires. I like this because it's more user-friendly. All you do is go to the wires and you test it. And I can show you real quick how that works. So you turn it on. And then we can see here that I have my switches for my lights. And you can see it will flash red if there's power. And then since I have my outlets still powered on to the breaker, you can see it's red, indicating that there's power. So if that happens, then that means either you turned off the wrong breaker, or there's somewhere that their power is still being energized in the system. So do not try to attempt it to do this until you get all the power turned off to those systems. Safety first. First thing of safety glasses. Very important. You want to make sure you're wearing safety glasses so that when you're up on the ladder, depending on where the fixture lights are, that there's dust or debris. You don't want to be rattling that fixture around and then you get debris in your eyes and it causes you to see or cause damages to your eyes. And also it protects your eyes if you accidentally clip a wire and a little spark came out and that it doesn't go in your eyes. Second step is to go over to your electrical panel, wherever it's located, either in the garage or outside, and you want to make sure you find the circuit that is for your shop lights. So I already went ahead and I already turned off the breaker, and I also turned on the light switch for the last hour, so that way that it will de-energize any residual power that is in those ballasts. I'm going to show you how to make sure that there's no power turned on. So here's this voltage tester. I turned the circuit back on so I can show you what it looks like if you still have power to the system. So we're going to push this power button to turn it on. Turns on. And then you just go over to the hot wires. So you can see that you have power. And you do not want that to happen when you are working on the power. So I'll show you what it looks like with the power turned off so you know it's safe to work on. With the circuit back off, we're going to put the tip on the wire, and you can see it is not red. And we're gonna come over here, make sure that there's no power. Yep, there is no voltage, so we are safe to continue. All right, to start, I'm gonna pop off this cover with my flathead screwdriver. There's gonna be a couple tabs here that you need to twist open. If yours has twists, if you have screws on yours, then you just need to take the screws and unscrew them. Basically just wanted to bend these, and you don't want to bend them too much where you break them, because you will need to push them back in once you get this done, so you can cover the ballast up. Okay, and then I'm going to repeat the process in the back so I can easily get access to it. When you have that done, you want to gently pop it down and lower this down, and then set this aside. So here, that's the ballast that we're going to be working on. Usually, you'll have your neutral, which is white, this white wire here, and then your hot, which is your black. So let's go ahead and start disconnecting these wires. And what you want to do, and per the manufacturer, it says about 6 inches from the ballast, that is where you want to clip the wire. So I'm going to go yellow. I'm going to go about here, disconnect. And you can see that yellow is going to the one side, and then over here you have wires that go to the other side. Usually one side is going to be your hot, and then one side is going to be your neutral. So we're going to go here. Okay. And then now we have to disconnect and untangle this mess. All right, I've ran into an issue, which that's always happens, so it's always good to be prepared. With this ballast, you can see there's a crimp right here to connect the power from the main power line coming in from the ceiling, from the main fixture up in the ceiling. That if I snip this wire off, it's not going to be long enough to reach these 4 wires over here, because I need to be able to take this hot wire and connect it to these. So I, luckily enough, have leftover 14 gauge black wire from working on the Taylor Dunn golf cart by doing some wirings on there. So this, what I'll do is I'll disconnect this wire here, which exposes these solid wires which come in from the fixture. And then I'm going to run this wire, get myself some proper lengths. And then you also got to remember that your 1 amp fuse is going to be going onto the hot, not the neutral, but the black hot wire. So with how long these strands are, just go like that. Roughly kind of go there. So looks like I'm going to need this much right here. Straighten it out. And I'm going to be using my zip ties to kind of do some wire management in here, so that way that it doesn't dangle down and it's not making a mess in here. So we need to take our wire strips and kind of strip back. So normally I kind of strip back about that much because you want to make sure that you have enough wire exposing so that you can connect it to the existing wiring so that you can get a good strong connection. I'm going to twist that. So that should be enough. And then I'm going to do it on the other side. So we got that. And then what I'm going to do is I'm going to set this aside. Just hang it up here. Luckily having exposed trusses, I don't have to worry about having to figure out where to place it and have to get up and down the ladder. And then we're going to disconnect. You know what? I'm just going to disconnect it here because the neutral is going to connect to these. So I'm just going to snip there. And then now our ballast has been fully disconnected. One thing I did forget to mention, that there is a little nut on the side that holds this in, so using a wrench will help take that off. So let me go grab that. All right, with that nut out, it should just slide right off. There's the old ballast. And now for the fun part, wiring everything back up together. So we're going to start with is attaching the neutral wire to the yellow wire. So what I'm going to do is I'm going to kind of come in here and kind of shorten this up because I don't need this much. And then take your wire strippers and then do the same thing. Kind of get yourself enough spacing like I showed you before so that you can get a tight, secure connection. Just like that. And then take your wire twists. I always call them wing nuts, but somebody put it in the comments saying that it's not called wing nuts, they're called wire twists. And then you want to get the wires and then kind of push them to your finger until they are leveled. And then you just take your wire twist, push them in there, and just rotate, tighten it down. And then one tip that I like to do to make sure that it's not loose, kind of pull in the wire to make sure that you don't have a loose wire. Because if you have a loose wire that's not fully connected, then you don't have a tight connection. So these ones are this one's all connected and ready to go. So I'm going to set that right there. And then now, let's connect the fuse. Pull the pre-cut-ins. Sometimes they kind of cut them short like this. I think I'm going to cut a little bit off, just a little bit more. So I have make sure that it actually gets a tight connection. And then twist the ends. And then we're going to take a twist nut, and then we're going to attach it to these wires. Same thing, push the wires up to your fingers so that they're nice and even, and then twist until it's nice and snug. Same thing, kind of give it a little tug to make sure it's not going to go anywhere. And then take our pre-cut wire, same thing, push it up to your finger to make sure it's nice and tight, and then twist. Give it a little tug. And now that is secured. And then let's prep. Let me move the ladder back a little bit so I can get a better angle at that. Same thing. Seeing a pattern here? It's pretty self-explanatory and pretty easy. Just strip, align, twist, tug, and done. Some of you are wondering that why are you connecting these four to the hot side? Well, per the manufacturer instructions, it does recommend attaching the yellow wires to the neutral, and then attaching the black hot to the red and blue, or to the 4 wires on the end. Basically indicating that this side's going to be your hot, and that side's going to be your neutral, so that when the bulbs go in, it creates a circuit to do a complete 120 setup. It's not just because I feel like it, but it's because of what the manufacturer recommends. And now you just take our wire, and repeat. Align the wires. Then give it a little tug on each of the wires to make sure they don't pop out. Then cut extra. And a little good tip that I've learned is that when you're cutting zip ties, instead of using the flat back end of going up to the zip tie and cutting it too short, if you use this beveled end and lining it up to the zip tie and cut it, it leaves just the perfect amount of at the very end, so that if you need to either tighten it up, you could be able to take some like needle nose pliers and be able to kind of tighten it up a little bit if it needs to, so that if you cut it flush, then you're kind of trying to push the back end of it and trying to get the exposed. And make sure everything is you have no exposed wires. Make sure everything is all connected. Inline fuses in with the 1 amp glass fuse installed. Don't forget to put the glass fuse in the fuse holder. If you do that and you turn your lights on and there's nothing happening, then first thing I would do is check that fuse to make sure that you actually put it in. Time to put the cover on. And then make sure when you're putting this back in that you put it in without pinching any wires, because you don't want to pinch the wires and then cause a short somewhere. That thing installed, and then now take your hammer, your flathead screwdriver, and pop those back over. With this cover being back on, let's put the new bulbs in and see if it turns on. let's go turn on the power. Look at that. Got it all working. That's 1 down, 3 more to go. All right, got it all hooked up, got all the bulbs in and all the fixtures. Time to turn on the breaker and test it out and see how much brighter it is in here. All right, turn on the breaker. And let's do a reveal. Let me turn off my lights. Moment of truth. 3, 2, 1. Just kidding. All right, here we go. 3, 2, 1. Wow. Look at that. All 4 of the fixtures turned on. And holy crap, it is so bright in here. I can actually see in my shop. Holy crap, what a difference it makes having all 4 fixtures running at the same time. Let me just say that this is going to be a major improvement working on projects in the shop with having this much light. Unfortunately, when I went to go try to get these direct wire bulbs from Lowe's, I was trying to get the exact same color that I had before, which was the cool white, which was I believe it was a 4200 Kelvin. This one's a where is it? 6500 Kelvin, which is a daylight, which is a very brighter color. My phone doesn't, it kind of makes it kind of color corrects it, but it does have kind of like a little of the blue-ish tint to it, which kind of makes it almost kind of like a sterile, like industrial area. I actually kind of like it. For me personally, I like having a little bit of a brighter color in here so that I can actually see. Some people might not like that bluish hue to it, but for me, it doesn't bother me. If it does, I could probably order the cool white if I want to and just keep these as backups. But unfortunately, I think I'm going to keep them. And with how bright it is, I don't think having that light above my workbench and also that one I put in the back is even worth it. But it is kind of, you can see, kind of dark a little bit back here. So if I turn on my switch, it makes it brighter. So I think I might just keep it. I might just eventually replace that one because that one is supposed to be a cool white. And then this light right here is actually the same 6500 Kelvin light. So that one matches perfectly for over my workbench. But over here, I think I might try to get the replacement one of that, but they didn't have it at the time when I went to go pick it up. That is how you retrofit your old fluorescent 2-bulb system that has these little ballasts in them that ignites the system to the direct wire LED setup. With having the direct wire LED setup, it allows you to be able to just replace the bulbs as needed if the bulbs burnt out. But if you do choose to just replace the whole fixture with an all-in-one sealed LED fluorescent system, then that's an option too. I personally don't like using those or want to use them because with them being a sealed unit, if one of the LED strands or strips that are inside the sealed unit go bad, there's no really way of fixing it unless if it's under warranty by the manufacturer. But if you had them for like 5 years or longer and one of the strands burns out, then you're gonna have to replace the whole tire fixture. And those fixtures can go anywhere between 80 to like $200, depending on what type of, like the size that you're wanting, and also like what type of brightness you're wanting them. With these being the two bulbs, then I can easily just replace them with the brand new bulb if I wanted to. But with these bulbs, they do have a warranty through the manufacturer. I believe it's 5 years, so if anything happens to them, then I can just request a replacement and they'll send out a brand new one. But LEDs have a long history of lasting anywhere between 15 to 30 years, depending on the usage. I think that's a benefit because that will save money coming out of your pocket having to replace bulbs. I remember when I was working at the auto parts store, I remember before they converted to LEDs, I remember I was going through those fluorescent bulbs. I was probably replacing them maybe every 3 to 6 months, and just replacing them because they would just burn out. And when one burns out, then you replace it, and then another goes out. It's like a daisy chain where it just goes down the line, and eventually you're gonna have to start the process all over again. With LEDs, they just last so much longer and so much easier, and also more energy efficient. Some of you might be asking, Dylan, is doing a direct wire setup even worth it, and is it even more energy efficient than just doing a direct replacement like you did in part 2? The simple answer is yes. The numbers don't lie. Look on the screen, you can see that when we did our test with the LED replacements, you can see that I was using about 1.98 to 2.3 amps at 120 volts, which gave us between 0.238 kilowatts and 0.276 kilowatts, which was averaging about 51 cents for running it for 12 hours straight to 59 cents for 12 hours straight. And that was from the old fluorescent tubes. It was an efficiency of like 57.2% efficiency by going with the LED direct replacement. But with the new direct wire and removing the old ballasts, you can see that I'm pulling between 1.67 to 1.83 amps at 120 volts, which is about 0.20 kilowatts to 0.22 kilowatts. And if we break it down, that's an efficiency from the direct replacement to the direct, the direct wire, is about 17.6% more efficient. And if you break down the numbers from the old fluorescent tubes and take the numbers from the old fluorescents to these new direct wires, it's even more with the 64.7% efficiency. And with that, it makes it so much cheaper to run. And to run it, it was averaging anywhere between, like on the high end, 47 cents for running it 12 hours straight. Some people might think 47 cents for 12 hours straight is not that bad, but it adds up the more that you use it. And if you're in an area where you get charged peak hours, where if you use power during peak hours, then your rates go higher. And man, that will make a huge difference if you're not pulling that much power. I would say, in my personal opinion, that doing direct wire LED replacements and retrofitting your old fluorescent tube bulbs that have these ballasts is more cost effective than just leaving them be. I know it costs money in the beginning, but the investment's well worth it and you'll get that back. Some states actually have an energy efficiency program where they will give you a rebate or give you a coupon by replacing your old fluorescent tube bulbs, especially if you live in one of the 5 states that have banned the usage of fluorescent tube bulbs. Always contact them and see if they have a program that does have those rebates. Unfortunately, at the time of the recording of this video, there was a rebate, but unfortunately that rebate has expired. So all you people that live in the state of Oregon, unfortunately that program is no longer available, but there are other places that you can get discounts on LED bulbs. So thank you so much for watching. If you haven't already checked out part 2 of me converting our shop lights to these new LEDs, check that video out. Links to it will be up in the info card and in the description down below. Thank you so much for all the new subscribers who have joined the channel since then. Welcome. Thank you for being here. If you love the content that I post on this channel, and if you love seeing how-to videos, go ahead and click the subscribe button. I try to post about once a week or every other week, depending on if I have any projects in line in the queue. And if you haven't already, click the bell notification, because in part 3, I have some juicy ideas I'm going to be sharing with you guys, and an awesome project that I can't wait to share that I'm doing in the background. So if you click the bell notification, the second that video goes live, you'll get notified. And if you haven't already, check out our social media platforms over on Facebook and Instagram at Dylan's Outdoor Garage. There I post behind the scenes sneak peeks and never been seen before footage that won't get to the full videos. And also it's where I announce the dates of when the new videos will be uploaded, and also updates if things get delayed. So if you haven't already, check those out. Links to the social media platforms will be in the description down below. If you have any questions or suggestions on what I should do with this home edition series, drop them down in the comments down below. I do read those comments. I love reading all the comments that you guys post. By posting those comments on there and giving your suggestions, I'll try to see if I can make it work or not. If I can't, I apologize that I can't do it. But if it's a great idea, I'll make sure to mention you on the video that I create of me doing the project. So thank you so much for watching. I hope you have a beautiful rest of your day, and I will see you in the next video. Take care now. Bye-bye.